Have you ever wondered how companies like Spotify manage to offer multiple versions of their APIs while keeping everything running smoothly? It sounds complicated, right? Well, today we're diving into the world of API versioning and database schemas to uncover the secrets behind it. I totally get your confusion. It can be really daunting to think about maintaining older API versions for years, especially when database schemas are constantly evolving. You're definitely not alone in this concern. Let's break down the specific question at hand. One user asked how Spotify manages to maintain older API versions while dealing with potential database schema changes. They presented 3 possible solutions, but none seemed ideal. Sound familiar? Let's explore this together. So, what are the challenges here? When you create a new version of an API, you might need to change the database schema. This can lead to issues if older versions are still in use. Understanding these challenges is crucial for finding a viable solution. And stick around. At the end of this video, I'll share a surprising insight that could change how you think about API versioning forever. To maintain multiple versions of an API with different database schemas, the user can implement a strategy called version database migrations. This allows each API version to have its own schema while still being able to access shared data. The user should start by creating a separate database schema for each API version. This means that when a new version is released, a new schema is created, allowing for changes without affecting older versions. Next, the user can implement a data access layer that abstracts the database interactions. This layer can handle the logic for which schema to use based on the API version being called. Additionally, the user should consider using feature flags to control which features are available in each API version. This allows for gradual rollouts and testing of new features without disrupting existing clients. Finally, the user should establish a clear deprecation policy. This policy will inform clients when an API version will be retired, giving them time to migrate to newer versions without sudden disruptions. Fun fact: did you know that the concept of API versioning has been around since the early days of software development? It's fascinating how far we've come, yet the challenges remain. Now let's look at the answers provided by other users. One user speculates that Spotify's microservices might not store data directly. Instead, they could act as a presentation layer over an internal service layer. If a microservice owns data, it likely follows one of 2 approaches. First, schema consistency might be enforced at the service level, requiring all versions to update with any schema changes. Second, each version could maintain its own independent copy of the data, possibly using a pub submodel for updates, although this could be inefficient. The user emphasizes that maintaining a static schema long-term is impractical, as changes are necessary. They highlight that one of the main benefits of microservices is the ease of making changes due to their small, contained domains. This allows for safer and quicker adjustments, including changing storage mechanisms. Here's a thought. What if there's a simpler way to manage API versions? By focusing on clear communication between versions and maintaining a robust migration strategy, you might just find a solution that works for you. And there you have it. Navigating API versioning and database schemas can be tricky, but with the right strategies, you can make it work. If you found this video helpful, don't forget to subscribe for more insights and tips.